So you can paint your room in 12 hours. Your friend can paint the same room in 20 hours. How long does it take for both of you to paint the room if, that should be if you are working together? Okay, well, that's a good question right there. Expect more of that, these typos in the future. So, all right. So we got two people working together, right? You got you, and then you got your friend. I'm going to put pal because it's a shorter word. And I literally do not want to write those extra 3 letters. Unfortunately, though, I've got to write this long word. We got to look at what happens when you do it together. Okay. Now, let's focus on each person. And again, I'm looking at doing this, looking at jobs for some number of hours. Again, when we say hours, it's not like, well, I guess it kind of is, but it's hours. How long does it take you to do that job? All right. So when we look at you, if this was a 9th grade class, I'd say, not that anyone wants to look at you, but in any case, so you can do one job. So in other words, you can do one. You can say job. I'm going to put room on this one. Again, I'm labeling it, but the label isn't really necessary right here. But you can paint one room here. Okay, that's the job that you're doing. Well, how long will it take you to paint that room? Up here it said that it's going to take you 12 hours. Yeah. One room, you can paint this one room in 12 hours. Now, thankfully for us, your pal is going to paint the same room. So again, we're going to look at your pal here now. And we know your pal can do the same exact room. So that's one room, that's the same job. Well, how long will it take your pal? Your pal's apparently much slower than you are, or more thorough. We're not really.
That probably's only good for drinking.
Yeah, up here it said, hey, your friend, they can do it in 20 hours. So again, we're kind of setting up a bit of a fraction right there, right? Now the question says, we want to know how long it takes for both of you to paint. That's why I should have said both because it's a shorter word. But together, you're going to do the same room. So as a fraction, you're looking at one room. It's the same exact room. We just don't know how many hours it's going to take. So I'm actually going to define the variable. X is how long it takes hours
Yes.
together. Yeah.
So you can put it as T, 1 or X, whatever.
Yeah. I like to use X just because I'm used to it. But yeah, use whatever you want. T, for some reason, if you want to use A or whatever you want, it's fine. Yep.
Or L.
Yeah, I don't mind.
Q.
Boom, do it.
Thanks.
Just be careful with L's and O's. That's all that I recommend there. So, well, how long will it take you to work together? X hours. We don't know how many hours that's going to be. Okay.
This is plus equal.
Yes. So we're going to take your work and add it to your pal's work, and that's how long it should be together. Okay. So this is how the fraction. Is this a rational expression like we've been seeing? Not quite, because we're not seeing a binomial or trinomial here, but it still is an equation of those rational equations here in this case that we have to solve. Now, so here's what I'm going to do. I'm going to rewrite the equation, okay, just without any of the labels. So it's 1 over 12 plus 1 over 20 equals 1 over x. Now remember, just like we saw last lesson, it's an equation with a variable, particularly in the denominator, right? So what we would like to do here is get rid of all of the denominators so we can rewrite the equation without any denominators. So at this point, I'm gonna force the denominators to match. And when I do this, personally, I like to force the letters to match, if there are any. And I do, I got this X right there. So if I can just get the X's to match, I can worry about the numbers later. We have a little bit more experience, hopefully, with the numbers by now. But if we just can get the X out of the way, right? So I just want X's to match. So I'm gonna give the 20 denominator an X. But again, if you multiply that by X, you gotta multiply the numerator by X also. All right? And then the 12, it also is missing the X denominator. So I'm gonna multiply it by X. And if I multiply it by X, I've got to multiply the numerator by X. Okay, so this is where I'm at right here. So I got the X to match in all of the denominators, which is a great start. And it was fairly easy for me because I didn't have to think, what I got to multiply these by, okay? But now I've got to do it with the numbers. So I've got 12 and 20. I would like a,
Full factor?
yeah, a common factor right here, common denominator here.
But it don't happen.
And it doesn't have to be the lowest. Remember that? It doesn't have to be the lowest. It just has to be common. Now, a common way to do it is just to say, well, I'm going to take the 20 multiplied by 12, 12 by 20, multiplied by x by 12 and 20. I'm actually going to go for the lowest common one just because it's going to make the number smaller, which hopefully makes us feel better inside, but I don't know. The lowest common denominator is the lowest common multiple for the numbers. So I'm looking at 12 and 20, right? Now, in the past, you'd say, you know what, I'm going to list multiples of 12 here, and that would be 12, 24. I know it's small, but there's not very many.
Go to 60.
48, yeah, 60 is the one. Okay, so we get to 60 right there. Well, what do I got to multiply 12 by to get to 60? 5, boom. So I got to multiply, again, both numerator and denominator by 5. And that will guarantee a denominator of 60. Okay, so now I said 60, I kind of jumped to that conclusion because I know 20, a multiple of 20 is also going to be 60. It's the third multiple of 20. So I'm going to multiply 20 by 3, and then I've got to multiply the numerator by 3. All right, and again, the purpose of this is to force, I already forced the x's to match. Now I'm trying to force the numbers to match. The last problem here, because we get so used to just adding fractions like this, it's like, hey, I got my denominators to match. No, we need this one to match too. Don't forget, it has to be all the denominators, because a lot of the times this is what students miss right here. They miss this one right here. They say, I got 5x over 60x plus 3x over 60x equals 1. No, you didn't have the common denominator, so you can't do that yet. So we're going to do that by multiplying the x by, well, we wanted those denominators to be 60, so I'm just going to multiply by 60. That was pretty easy because the coefficient of that x, specifically in the denominator, is 1. But if I do it to the denominator, I've got to do it to the numerator. All right, so this is going to give me a new equation. I'll work here to the right, and then I'll work down. But what I get then is from the first fraction, 5 times, again, I'm just looking at the numerator, 5 times 1 times x is 5x. 5 times 12 times x would be 60x's. And by the way, once you get enough experience, I think a lot of students would skip this step, and if you do, that's fine. But if you never want to get that much experience, then I get that too. But in the numerator of the second fraction, right, 3 times 1 times x would be 3x's all over. 3 times 20 times x would be 60x's. So again, we're seeing that the denominators are, in fact, matching. And this would equal 60 times 1, which is 60, all over 60 times x is just 60x. So we have gotten the denominators to match at this point. And now, just like we saw in the last lesson, I'm now going to rewrite the equation, but without any denominators, okay? Because once the denominators match, you're just dealing with the same size pieces, and so it doesn't matter if you add, subtract, multiply, or divide them. So now what do I got? I got 5x's plus 3x's. It's kind of a jacked up plus sign, there we go, equals the 60, right? Because I got rid of completely the denominators. Well, if we had started with this equation, we may not have rejoiced because it's still math, but we probably would have thought, yeah, I feel like I can do that. So let's continue there. From the 5x plus 3x, I know I can combine these like terms, these x's. So 5x's plus 3x's would be 8x's. And this equals 60. Last thing I need to do here to solve it, again, x. What does x represent? It represents, we defined it up there, x is the hours that it would take to do the job together. So I'm going to divide both sides here by the coefficient of 8. So this would be like doing 8 of those right now. It would take you, if you did the 8 of the jobs, it would take 60 hours. But we only want one of the jobs, right? How many hours would it take to do one of them? I'll go back to green because that's the color I defined x is. So x equals, oh, I should have my calculator, 7.5. So again, x was hours together, and this is a word problem. If you see a word problem, make sure you label it, okay? So it's 7.5 hours. And the fraction's okay on that one. which I think would be 15/2. You know, if you really want the fraction, but I think the decimal probably is a little bit more clear. And that, you probably wouldn't go to someone and be like, it takes 15 hours for me to do this job with my friend, but you're welcome to, you're welcome to do that with people, so. Now, this one was nice, right? It's like, okay, we just got some X's here, we just combined the like terms here at the end. But again, a lot of the students struggle with just setting this up together. Again, you only got 3 parts to it. You got your friend, and then you got doing it together. And then understanding that these fractions kind of set up as how many, I put up here jobs because it may not be painting a room, right? It may be pipes putting out water, or I don't know what they're gonna come up with, but something, it may be just a different job, right? Like, you two can build a house, you can build a house by yourself, and I don't know, whatever.